Now you can use MLatom to perform TDDFT and TDA calculations with PySCF as well as TDDFT calculations with Gaussian. You can also parse Gaussian output files with MLatom to get them into MLatom data format. In a nutshell, to perform these calculations, you just need to define your functionals and basis set and put a prefix TD or TDA dash for PySCF. For Gaussian, it would just work with TD. And also, you need to sometimes save your Gaussian output files. Then you need to request in which directory you want to do this. Once all this is set up, you can use MLatom to perform excited state calculations with these methods, either for a single molecule or for molecular database, which can be very useful if you want, for example, to calculate UV spectra, either with single point convolution. When you perform these simulations, you can then plot spectrum using the molecule for which you perform TDDFT calculations. Or you can calculate for the whole nuclear-ensemble with TDDFT, and then you can plot also spectra by using nuclear-ensemble approach. To this release contributed several people, me, and also we have a new contributor, Vignesh, and Ifan also contributed. In addition to this, we also have, as mentioned, a new feature that you can parse existing Gaussian output files so that you can obtain a molecule in the MLatom database format, and then you can dump it in this database format in, for example, JSON file, and reuse it later for some other calculations. For example, machine learning of excited state properties.